back. Something died with internet. It seems like we're back. All right, so let me click kernel, restart that kernel again. Now internet seems to be working. Now I have access to my Python again. All right, so what I was just showing was giving some value, giving some doc strings that tell me what I'm trying to do with my function here, and also some hints about how to use the function and how I defined it. So whenever if I define something like this, like x is not an array, sine and cosine, because these are NumPy functions, are going to turn x into an array and then give me, so it's changing it's changing this input from a list of values into an array of values. And sometimes that matters, sometimes it doesn't matter. But the key is give yourself some hints, be kind to your future self as you come back to try to fix or kind of debug your code. Be kind and give yourself some hints on how to use the code and what it's supposed to be doing. Yeah, so that was it. All right, so another thing that I noticed, and this is usually, like, everybody has trouble using timers, using this like time it function. And I noticed some people pulled in a time it, like they imported the time it function, which does work pretty well. But let's try asking, we'll bring this in. And here, it's giving two different things. Yeah, and even right here, ChatGPT is trying to time this print statement, which is, it doesn't make sense. Like, there's no reason to time the print statement. This is okay, like timing the code in a Jupyter. So here it's using that Jupyter notebook. And here, yeah, I don't know why it's showing me this side by side. But anyway, so one of the main things to think about here is, like, if you're using these, using ChatGPT here, and yeah, I'll grab this. We'll copy this over, paste it in here. How's my, yeah, we're good. And so it's gonna time it, it's gonna run this thing, I forget, maybe 1,000 different times. Yeah, 10,000 times, and then it finds that, all right, it's 94.5 seconds. And whatever, it works. But I just want to compare this operation with changing it to be this operation. So if I add a print statement, like print mean A99, like that, one, it's gonna print it out 100,000 or 10,000 times, which I don't need to do. And then two, now it's also timing how long it takes to print something, which is different. Like, I don't care how long. I either need to print it or I don't. I don't need to figure out, like, is printing the thing that is slowing down my code. Like, printing always slows it down. It's just, so all I want to do is time this, and here it's doing what I wanted it to. It starts at 0, goes to 9, and gives me the whole, like, multiplication table, and it takes 95 seconds. Now I want to compare that to just taking A99 equals X times Y, and I'll grab these two things just so it's the same code. So this code and this code is all the same because A99, all I'm doing here is initializing A99, and I don't need to do that if I'm using arrays. So I'll time this. This is also more compact, right? Like I don't have nested for loops to do this array operation. And here it takes, it's 14 microseconds faster on average, that's significant. And the bigger these arrays gets, the more time savings we'll have. The just-in-time compilers have gotten a lot more efficient, so these for loops are probably doing a lot of things a lot quicker than they used to. It used to be anytime you had a for loop in Python, that was killing you. Like it would take twice as long just to run through a for loop. Now it's gotten much faster. So for looping is not as big of a deal as it used to be back in like the Python 2 days. Python 3, 3.8 and up have gotten a lot better. But this is the main thing that I wanted to say here, is that when you're timing things, you're not using whatever's inside that timer function is just a minimal set of code. So here I just have these 3 lines. Here I have a couple extra lines, but all I'm trying to do is compare these two things. So I have these 2 nested loops here, but what I could have done is turn that into a list comprehension. So I times j for I in range 10, and then for j in range 10. Now it's starting to look a little closer to this, and I don't need to initialize an array. Like I don't have to create a 10 by 10 array because I'm going to do that on the fly here. And let's see how this compares. I still need to loop through 100 different things, like go from 0 to 10 for every 0 to 10 things. It does take a little bit longer because I'm not plugging values into an array, but here it kind of takes, it's a better comparison because I'm taking this value and comparing it just that one line of code. But it's always faster to use arrays, and it's a little cleaner to use arrays if it makes sense. Then one last thing. I think I saw some stuff in here that looked like ChatGPT kind of outputs. So I just wanted to see what we're getting, like what ChatGPT thinks we're trying to do here. So it's giving us like a little bit of some background, like, okay, you have this differential equation. This is the solution to that differential equation, and that makes sense. Then using Euler integration, this is the correct Euler integration formula. And it doesn't know what this data is, but it thinks that it can load it in. And it seems like it's doing stuff, and it is similar to. So I think I did see similar things here, where setting up a function and then integrating that function that way, and then this analytical solution, like comparing it that way. So we could start with this and then see how we can improve the work. That, and we'll come down here. Oh, yep. I get one of the nice things about using like ChatGPT is like all this stuff of like labeling, changing line styles, changing the colors. It does that like automatically, just because it's been done by so many different examples. Like its data set has people that have done that, so that's kind of nice. One of the things that I like to do is if it's within a function like this and I have commas, just put it all on new lines so that it's a little easier to look at and troubleshoot. So blue, green, and red, actual data. Where does the actual data come from? I mean, I would call this like measured population. And I want to put this as like square. I want to use square markers for that. And oh, what's wrong there? PLT dot, oh, because it already used a scatter plot. Duh. All right. Anyway, I don't need a scatter plot. I'll do it myself. So measure population are these red squares all connected, analytical. And again, also it's nice that it gave Euler integration like distinct data points, and then the analytical is like a smooth curve like that. Time steps. So here that time step, so let's see what time steps was defined as. So it uses a range to go from 1900 to 2021. That's cool. Analytical, we already, this one looks like the right input. Here, let's give it some default values. Oh, population 0 is pop 0. T0 equals year 0. And kg equals kg. Nice part about that is that I can just delete all those inputs and it's going to use my first year and my first population as default values. And again, I'm taking this and splitting it up onto multiple lines so it's a little easier to read, and it'll do that math for me. Euler integration, T steps. This is a good way to do it. So what we're doing here is T steps, kind of a weird. It's weird that we use T here and T steps there. I don't like it. I just don't like it. I like consistency. If I'm gonna have some code that I need to say is my code, like I need some consistency here. And again, let's do this. P0 equals pop 0, and then kg equals kg. Now, yeah, this one, I don't like this. I don't like to do this where I create a list and then keep appending to that list. It used to be really slow. Now it's gotten faster, but this is my preferred method. Set up a big empty array that is the same size as my input time, and then say population of 0 is P0. And now as I loop through that time, I'm I'm not saying that, I'm not appending that value of P next. I'm saying population of I equals P next. And then this is going to be I minus 1, and this will be I minus 1. So I'm going to start at 1, which means population of 0 plus 20 years times that 0.013, this growth rate, times that population 0. So our like 1.6 billion people in the year 1900. And I'm not really changing anything here except the fact that I don't need to turn population into an array. I can just return it now because I create an array that is the right size that I want, and then I return it at the end. And it doesn't change the output at all, but it makes it a little easier for me to kind of troubleshoot and think about how this problem is working. And yeah, time steps. Why do we... And this, I don't need that down here. I need this like in here, right next to where I'm using it. Yeah, well, that's fine. But I don't need to give it P0 and kg anymore because I defined some default values. And this is a pretty nifty way of doing stuff where maybe you have values that you want to change, but for the most part, you've got something that you all like. This P0 is always that population at 1900. And this world data, I already loaded all this, so I don't need to do it again. I mean, I guess the only difference here is now I have to change this to year and this to pop, because I already loaded it in as year and pop. Yeah, we'll do that. So I'm changing the spacing of this stuff, but inside these parentheses, you don't need to change. So inside these green parentheses, I don't need to change where the spacing is. It's different from when I'm defining a function where everything is tab based. But once it's inside those parentheses, you're good. I just like to do it for my own sanity when I'm looking at it. And do I want this grid? I don't know. Wait, the grid is still there? Get rid of the grid? I don't know. That's up to you if you want the grid or not. But the legend, yeah, that one looks nice. Cool. This is our key formula for like doing that Euler integration. All this other stuff of like setting up, like initializing that population, all this, that's all like fluff of like it'll change each time. But this is really, and that's what we have up here, is that is the Euler integration formula. So that's the important part. Everything else is just, it'll change, but we can create a function that just does this. We don't need to create an Euler integration function that is specific to this problem. We could create like a general formula that will integrate any kind of differential equation, which we'll get back to in module number 3. But for now, we've got something that works. And the nice part about turning it into these functions like this is that you can play around. It's easier to play around with like P0 and kg if you wanted to see different options and those kind of things. So anyway, hopefully these are helpful hints for homework 1 as you go back and revisit some of the comments that I left, or if you were just thinking a little deeper about like, why are these questions being asked? How do we do this? How do I use ChatGPT for these kind of problems? Hopefully this helps. And again, a lot of this was generated with ChatGPT, so I would say like code modified from ChatGPT, interaction, and prompt engineering. Again, to help understand like why did you decide on a fig size of 10.6? We don't even need the fig size of 10.6. It'll give us a figure. It does change where this pops up, and maybe I want to change that. I don't know. And maybe I want to put this on a new line like that, so it looks a little better, but that's what that /n does for me. Cool. All right. Again, hopefully this all helps, and I'm looking forward to seeing project number 1. We'll get that in on calendar, due dates on this the 6th, so Monday. So we got today and take the weekend off, but then Monday we can get back to it. All right, cool. And then we'll jump into homework 2, start working on that. And now we're squeezing stuff in. Okay. Have a great day. Have a good weekend. Bye.